various glues have set on the motor mount and on the payload section, so all that stuff is ready. And we are now going to start in on the fins. So the first thing I'm going to do here is just sand the surfaces of each fin. I'm going to start with some 100 grit sandpaper here, just to do the initial sanding here, kind of get rid of these scorch marks, and also then to do the initial shaping here. So make sure you're sanding with the grain for optimal results. Okay, now when I'm doing this on smaller model rockets with balsa fins, I'll usually start with 150 grit sandpaper, but because this is plywood, you'll just spend a lot less time if you use the 100 grit here. So the next thing I'm going to do is round over the leading edge. I'm going to taper the trailing edge, and I'm going to leave the tip edge here alone. I may just give it a little bit of sanding to remove some of the scorching there. But this is always going to be a trade-off between how tough the fins are going to be and how aerodynamic they are. Now, I actually need these to go up fairly high for my scientific endeavors, so I'm going to fully round the leading edge and then taper this trailing edge, so we got kind of a pseudo airfoil going on. The drawback to that, especially with having the taper here, back here on the trailing edge, is it is more prone to chipping. Okay, so the nicer you make that taper and such, it does weaken the material a little bit, and that's a trade-off you have to do. All right, you could leave it completely unsanded here and it'll still fly, just not as high. So for the leading edge here, the first thing I'm going to do is just start by knocking down this corner edge here and making it more of a slant. Now I am just using a simple piece of wood here. It's a block of wood that has nice flat surfaces to hold my sandpaper. And I found this works just as well as more expensive store-bought sanding blocks and sanding teas and things like that. But it is easier on your fingers than just holding the sandpaper. Now if you want, you can also put this down against the edge of a table or something like that, so you can just hold it down while you're sanding. It's hard for me to do that under the camera, so I'm going to go ahead and hold both of them here. Okay, so if we look at this in cross section, you can see that it's just starting to taper inwards here. I'm going to turn it around and do the same thing on the other side. Okay. Now something else to watch for is, you can see right here, I'm not ground down quite as much here as I have here or over here, and this is simply due to biases in the way I'm holding things. So as I'm moving back and forth, I'm not necessarily putting quite as much pressure on the ends here. Okay, and that's just part of holding things. So if you're aware of it, you can come back here and compensate for it on the end areas. Okay, and I'm just going to keep going back and forth with this. And this middle area here, you can actually use the scorch markings as a guide, because as you get closer and closer, this is going to get narrower. And at some point, you're going to start rounding this over. So hold your hand at a different angle here. And eventually, you'll just roll over. Okay, now when you do that, kind of depends on how much of a taper here that you want. So some people just like to round it over and make it fairly blunt. I'm going to taper it a little bit more than that. All right, so I'm starting out at a more shallow angle and then coming up into the steeper one here. Actually, from this point of view, it's steeper. Okay, until we round those over. You just kind of rotate your wrist a little bit as you're sanding back and forth. All right, again, I'm going to check in cross section. Make sure I'm kind of tapering the same amount on either side. And also, again, looking at this little stripe here. Eventually, that's going to go away. Okay. That looks good. That looks good. Okay, so that one's shaped. Back here on the aft edge, the trailing edge here, I'm just going to make this more of a knife angle, so I don't have to roll so much as just sand a slant into it. Again, this is actually easier if you hang it off the edge of a table. Readjust my paper here just a bit. Okay, so this is down to pretty much a knife edge. I've got just a little bit of bluntness here. You can see that leftover material. I'm going to leave that there. Some of that is actually the interior of the plywood, so you're going to have some of that. All of my fins have been sanded and shaped, and I went with using 100 grit sandpaper to do the initial shaping of everything and sanding the surfaces, and then progressively went up to 150 and then 220 grit sandpaper. As you can see here, I've done a little dry fitting to make sure that the fins fit. Mine are pretty snug, but they do still go in. Now, if you do have trouble with it, there are a couple of things you can do. Using either a file or just a little bit of sandpaper, you can just remove a little bit of material on each end. Now, if the reason that the fin's not fitting is because we've actually got some rings sticking up into the slots here, it'll be easier just to sand or file off a little bit of the fin tab on either end until this fits. Okay, but mine looks pretty good this way. Now, the other thing I want to check for is this should be flat against the tube, and you should be able to kind of just feel the contact with the motor mount. Okay, so there shouldn't be a lot of gapping there. There's a little bit in the aft end, but that's okay. If it's really sticking up, so if you see something like this, that means you need to go in and sand down the whole length of the fin tab here. Okay, now mine is fine, but what I'm referring to here is you need to sand this part a little by little until everything matches up. You don't want to over sand this because we do want it to come in contact with the motor mount down inside there. So to put these on, I'm going to be making up some more epoxy, and as soon as I do that, I'll come back. I've made up some 5-minute epoxy, and I've also numbered my fins and the corresponding fin slots here, just in case there's some little bits of differences that might cause one fin not to fit as well in the other slots. So I am going to start with the first one here, and we really don't need a whole lot of epoxy on these, but we'll go ahead and slather on some here. We can be pretty generous because this will all kind of flow into the motor mount and onto the centering rings. I am going to actually put this standing up on its forward end so that if there are drips, they actually run into the forward centering ring. Alright, now we're just going to press this back into place like this. Okay, and here I really don't want any epoxy gooing out of there. I'll do fillets later, but I want to keep this pretty clean. And so we can wipe off the excess epoxy using alcohol on a tissue or rag, just like that. Okay, and press that inward. And then I'm going to repeat this on the other two fins. Now here, I also have a fin alignment guide. This one's made out of cardboard, and it's meant for a BT80 type tube, which is close to what I've got here. Right? This fin alignment guide is made by Apogee. Okay, and this, having the through the wall fin tabs does help with alignment, but this just gives me a little bit extra alignment here and help keep things in place. Okay, as soon as this sets, I'll go on to the other two and then I'll come back. Okay, I'm back again briefly. I'm not sure if I remembered to show this. Be sure to get epoxy here on the very leading and trailing parts of the root edge there. I'll go ahead and put this one on as well. Like that. Yeah, I think I forgot to show that on that first one. We'll fill that in with some epoxy when we do the fillets. While the fin epoxy is hardening, I've come back to the nose cone, and what I've done here is put on a layer of universal bonding primer. I mentioned this earlier, so that this is kind of an intermediary between the really hard to paint plastic polypropylene in this case, and then the future layers of primer and paint will go over this. Now you may notice here, it does nothing to improve the finish. In fact, it kind of makes the finish look even worse, but that's what gives it the toothiness or tackiness for the additional layers of primer and paint to adhere to this. So once this is dry to the touch, I'll put a couple of layers of primer on this, wet sand it, and then it'll be ready for the actual paint. Now, LOC kits usually have us mount the launch lug, and even just finding the place for the launch lug after we do the fins. And usually I try and catch that so that ahead of time we can mark where the launch lugs are going to go. I did not catch it this time, and so what they recommend is, first of all, just finding a place that's going to be halfway between two of the fins. And this is a good time if you've made a mistake or maybe a little bit of marring or something like that you want to hide, put the launch lug on that side. Okay, so I'm going to go about halfway between these two fins here. And then to get a straight line, we can't really put this in a door frame once we have the fins on. Alright, but we can use a piece of angle aluminum here. Alright, and I'm going to sight down that looks pretty close to straight there. So here I'm just going to make a nice faint line. All the way down the body tube. Okay, now on mine I want it to be able to use either a launch rod or a launch rail, so I'm going to put another line on here that I can use for my rail buttons. Okay, and we just do this in the exact same way. That angle aluminum on there, make sure everything's straight. put on another faint line. Now once you've got that, go ahead and sight down your rocket and make sure that you are indeed straight on both of those. Now you don't have to do both. If you just want to use launch lugs or just want to use launch rails, that's fine. You will save a little bit on both weight and drag that way. But I never know where I'm going to be launching. So sometimes I've got a rail, sometimes I've got a rod, sometimes I've got both. Okay, so now we're going to take the launch lug and it's in the small parts package here along with the parachute. Put that out of the way for just a moment. Okay, now they recommend cutting this in half but at an angle. If you've got a little miter box, you can get these in hobby stores. Okay, so you just put this in here. Now on mine, this is actually meant to go on the edge of a surface, so I'm going to scoot the camera here a little bit. You can see my disgusting floor. Okay. So here I need to measure halfway down, and it's probably a 6-inch launch lug here. Yep, so we'll just go at 3 inches right there. Okay. And so I can do a 45-degree cross cut on this. Right, get my handy dandy little razor saw here. So we just slide that in. Okay, I'm trying not to actually cut that all the way down until it hits the aluminum. That dulls the saw. Almost there. And we'll just take a knife and finish that cut. There we go. Now according to the instructions, the aft launch lug should be 2 inches from the aft end of the rocket. I'm actually going to do it right at the aft end of the rocket. We're close to it here. The reason for that is because this will give a longer contact time with the rod. And so the longer it stays in contact with the rod, the greater the chance it has of flying straight. Okay, so it can depend upon that rod while it's gaining speed for the fins to work. So if you can keep it on there longer, that's usually better, at least in terms of stability. And then the other one needs to go at least 10 inches forward from the aft one. Okay, but the real measure here, not so much for the launch lugs, but for the launch rail buttons, is how far down this is going to be. Okay, so for my launch lugs, I can actually put them all the way up here at the forward end of the rocket, which I'll do. When I go to do the launch lugs though, or excuse me, the rail buttons, they'll have to be down below this part here so that they don't interfere with the proper seating of the coupler there. Okay, so I'm going to go ahead and roughen up the tube a little bit. So down here on the aft end, and so I'm going to give myself about a centimeter there of room. Okay, and just use these as a guide, that's pretty good. Okay, and again up here I'm going to put mine up near the forward end of the tube here. should be okay. Now the instructions say to use epoxy on these. Frankly, wood glue will do just fine. Either one you can do. I'm going to go ahead and use epoxy because I'll also epoxy the fillets on this as well, and that dries faster. If I use wood glue, it's going to take several hours to get to the point where I can fillet them. So the other thing I'll do right now is sand the contact point of the launch lug there. Okay, and I'm going to go off camera for just a moment to make up more epoxy. Now to make things easier, I've put this up on a rocket stand. And I've made up some 5-minute epoxy here. Scoot this over just a bit more. There we go. Okay, and so I'm going to coat the underside here. Let's see if we can do this and stay in focus. Alright, so the area of the launch lug that we sanded here, I'm just going to put a little bit of epoxy on. Alright, we don't need a whole lot at this point, because we'll come back and do fillets later. Okay, and now we're just going to put this down on our sanded region along the line. And now I'm going to sight down the rocket, trying to make sure that my line and the rocket and the launch lug all line up, and they're not. Move that over a bit. Try again. Okay, it looks reasonably good. Okay, now I'm going to come up here to the forward end. Now I've temporarily attached the payload section here just to give it some weight, otherwise it comes unbalanced on my stand here. Okay, we're going to treat this one just the same way. Just a nice even coat of epoxy. And then we'll put this on, and this I'm going to put this almost up to the edge, but not quite. Alright, and now we're going to sight down the entire rocket. I'm going to move that out of the way. Alright, so I'm looking through the forward launch lug at the aft one and at the line. Everything should all line up, and that looks like it is. Okay, so I'm going to let that harden, and then we'll come back. The epoxy on the fins and the launch lugs have hardened, and so now I'm getting ready to put in the fillets. There are a couple of ways to do this. I'm going to do this freehand. But the alternative is you can put in masking tape and leave yourself about 5 to 6 millimeters here, or around a 1/4 inch on each side, and even up on the fins. I'm feeling very confident today. We'll see if it holds out or not. But you can do this without the masking tape, just using your fingers. Now, definitely have gloves on because you're going to come in contact with the adhesive here, and epoxy can cause allergic type reactions. And I'm also wearing very tight gloves here, so tighter than I usually do, because we want a nice smooth surface on our fingers. Alright, we're also going to want to have some rubbing alcohol on hand, and I've got some here that I have in a little squeeze bottle. It really doesn't matter what you keep it in as long as you have it handy. Okay, and then we also have lots of paper towels down below the rocket here to catch any excess and also to wipe my fingers on. Alright, now I'm going to do facing fins at the same time. Okay, so I'm just going to drizzle some in to begin with here. and just kind of use my applicator to smear that in further. Now I am using 5-minute epoxy. If you're new to fin fillets with epoxy, I would recommend a 15-minute one. 30 is just too long. It makes them tend to run. Okay, let me get both of the fins done here before I do anything else. And I recommend only making up enough epoxy to do one set of facing fins here. Otherwise you really get into a rush and you end up wasting the epoxy. Okay, now what I'm going to do is apply a little bit of alcohol to my fingers here. So now I have alcohol wetted fingers. And I'm going to use that finger or fingers to smooth in the epoxy here. Okay, and the reason for the alcohol is it temporarily dilutes it and it makes it so it doesn't stick to your finger. Okay, put a little more alcohol on my finger here, and we'll do this one. Alright, and then I'll let those harden. I'll do the launch lugs in the same way. Might just have enough epoxy here, at least for one side. I think I'm going to come up short. So what I'll do here is I'll go ahead and smooth in the stuff that's there. And then anything on the top we'll just wipe off. All right, I'll let that harden and we'll come back and get it with the other fins. Okay, so once this hardens we can move on to the next fin and move on to the launch lugs. I will do those off camera. Here I have the nose cone primed and sanded, and so in total this has had a coat of the universal bonding primer, 2 coats of the filling sandable primer, and then I'm going to overcoat this now with the final paint. While still waiting for epoxy to harden everywhere, I'm prepping the payload section for painting as well. Now this one I'm not even going to try and do the spirals, and they're not very deep anyway. So for this one I'm just going to treat it with a coat of white primer and then do the color coat on top of that. My epoxy fillets have all hardened, and at this point, depending on your preference, you can build those fillets up. Epoxy putty works really well for that. I'm going to leave my fillets the way they are. At the moment I'm hoping that the decrease in weight that the heavier fillets would have is more than offset by an increase in aerodynamics, and we'll see how it goes. My students are actually doing another one of these in parallel, and I may have them try the bigger fillets and see how it goes. I'm actually about ready to prime this, and so here I'm going to use a dead motor that's attached to a stick. Okay, and I can just put this right in there. Okay, and it's snug enough I don't need to do anything else with it. I'm going to pull it out briefly so I can wrap some masking tape around the threads of the retainer. There we go. We can fold the tape over. Alright, and that gives me a handle so I can hold on to this while we're painting and priming it. Now initially I'm going to prime the fins using a filling sandable primer. I'll probably have, overspray onto the tube, but the main part of the tube here, once I get the fins masked off and have them actually colored, is I'll do the rest of it with a white primer and then a white overcoat. So this is going to go back off camera and into the painting booth where I can start in on that. Here I've primed the fins with a filling sandable primer, and I didn't worry about getting the upper part of the body tube here, because right now I'm just prepping the fins. And what I will do next is sand these. If necessary, add another coat or two of the primer if it looks like they still need it. And then once that's been done, I'm going to spray paint one of the fins blue and another one red. And then once those have been painted, I'll mask those off and then paint the third fin and the rest of the body white. So I'm going to do all those things off camera and then come back. Here I have all of the components painted. So my nose and payload section are white, and then the main portion of the rocket here is gray with a single red and a single blue fin to go with it. I had a little bit of trouble with masking there. We got a little bit of a red stripe coming down, but I'm not too worried about it. So now we're going to start putting this all together. And let me clear off the nose and the payload section for a moment here. And then remove the tissue from inside so we can get to the Kevlar part of the shock cord there. Okay, now to finish this off, we've got our parachute protector there. And we also have the main shock cord here. This feels like it's probably polyester. Now you do have some other options, although it means you may have to buy some more materials here. If you prefer having a completely Kevlar shock cord, you can simply add on to this, or at the beginning of the model, start with a longer piece of Kevlar. And you can get Kevlar from Amazon as well as a lot of other rocketry retailers. For this, I'm going to go ahead and build it as the kit makers intended here. And the easiest way to connect this is just to slide one loop over the other. So I'm sliding the polyester loop over the Kevlar cord, and I'll take the other end of the polyester cord here, and I'll put that through the loop, and then we'll just tighten this all together. Okay, and so that should make each loop interlock with the other one there, and that's a nice strong connection. You don't have to put any glue on this because it's not going to go anywhere. Okay, now up at the other end, we can attach this one. Now, LOC does include a quick link just for this purpose. Okay, so to use the quick link, we'll just open that up, and that's going to attach to our eyelet here and also to our shock cord. Okay, now before I put the shock cord fully on, I'm going to go ahead and attach my parachute protector by simply sliding the shock cord through that little buttonhole opening. Alright, and then we can attach this here. Now, I'll let you know ahead of time, I'm going to detach this once I've got it on, because I still need to put on the rail buttons, and I don't want to take the chance of accidentally drilling into the parachute and the shock cord here. And that's the nice thing about the quick link, is you can do that. You take this all apart very quickly. Right, and we've got our parachute here. Here you've got a few options as well. So I'm going to gather up all my shroud lines here. The first is to simply gather all your shroud lines, make sure they're all the same length, and you can tie a big knot in this. Alright, so if I bring those all the way around in a water knot, and you can simply take all of those loops and hook them into the quick link there. Okay, now I'm going to do something a little bit different. I'm going to use some heat shrink tubing and a barrel swivel on this. Here I have a piece of heat shrink tubing and a barrel swivel. Now the heat shrink tubing you can get in just about any place that sells electrical supplies. So I got mine from Harbor Freight in an assortment pack. You want a piece that is as small as possible in diameter, but that you can still get the shrouds through. And then you want about roughly 5 to 10 diameters in length here. Okay, and that's a lot of that's aesthetic and up to just how you want this to look. Okay, so I'm going to go ahead and I'm going to open this parachute up first, just to make sure everything can slide by itself. Okay, and I'm going to find the center of the sheet. Okay, and then I'm going to get all of my shroud lines here. And what I want to do is get them untangled as much as possible. Alright, and I've got them all on one finger here, and I can come to the other side. And the idea here is to get all of these edges as close as possible. Okay, and so you can adjust by going either way there until those are all in about the same position there, just like that. Alright, so now I'm going to hold on to that and not let those slip. And the first thing we need to do is slide the shrink wrap over the shroud lines. Alright, if this is really difficult, then just get a little bit bigger diameter shrink wrap. Okay, so we're going to pull that down, give us a good sized loop to work with yet. Alright, this is a barrel swivel, and so we can do it on either side of this. Here you just want one that's rated to at least 10 times the rocket's weight. Okay, now I've got this hanging on my loops. Got my shrink wrap back here. Okay, I'm going to feed that entire barrel swivel through the loops. Pull the loops back and then pull that tight there. Now I'm going to make sure I haven't moved where it is on my parachute. That still looks good. Okay, and then we're just going to push this down until we're right above the knots there. Okay, now here's the tricky part, is we need to heat the shrink wrap without burning up the shroud lines here. Now you can use a heat gun, you can even use a hair dryer, although it tends to be a bit wide in its field of influence there. Okay, most of the time I just use a butane lighter set to its lowest flame. Alright, and then instead of going under it, I come in from the side. And I just heat that gently, and I intentionally keep my fingers near it, because if it's getting too hot for my fingers, it's probably getting too hot for the shroud lines and the heat shrink. Okay, you might turn that around there. Now the whole reason I'm putting on a swivel is, ideally at least, if the parachute is rotating, which they will do if the shroud lines are not completely even, and that's really hard to get most times. Or if you have imperfections in the parachute sheet, it just tends to twist as it's coming down. And having the swivel should alleviate some of that twisting, so your shroud lines don't just all wind up together and collapse the parachute. Sorry, couldn't see that there. Okay. Now, ouch. That's still hot. Don't grab that. Okay. Now what this is doing is it holds all these lines in place so you don't have to add glue to the knot here. Now you can if you want, but the whole idea here is this way, if I need to repair this, put in a new swivel or something else, all I have to do is take a knife and slit this to remove it. Okay, and this also makes changing the parachute out easier. So as I've mentioned before, this is actually going to carry a scientific payload, and it may turn out that I need a bigger parachute. In fact, most likely I will. And with this type of arrangement, I can just very quickly add or remove that. Okay, but that's how it should look here in its most basic arrangement, is that quick link should have the parachute, the shock cord, and then attached to the screw eye there. At this point, if you are not going to use rail buttons and are just going to use launch lugs, this rocket's done. All we have to do is put it together. I'm actually going to take it apart here a little bit so that I can put on rail buttons in addition to my launch lugs. And the reason for that, it just gives me more options on the launch field, so that if I'm not bringing my own launch equipment and I'm using, say, a Rocket Club's equipment, they may or may not have rails, or they may or may not have 1/4 inch launch rods available. So this gives me a little bit more flexibility, even though it does cost me a little bit more drag. I've removed most of the recovery system again so that we can concentrate on the rail buttons here. And we need to make a couple of measurements and then make some markings on the body tube. So at minimum, my forward rail button needs to be below this point. Okay, so if I'm measuring here the coupler and including my screw eye here, that's about 9 centimeters. I'm going to give myself an additional one, so I'm going to say 10 centimeters from the forward end. Okay, and then I also need to make sure that I'm hitting this aft centering ring. Okay, and according to this, that is about, we'll call it 13 millimeters. The thickness is 3 millimeters, and so we want about a half there. So we need about 14.5 millimeters from the aft end. Okay, so what I'm going to do here is find a location that is roughly between two of the fins. Alright, and then we're going to measure 14.5 millimeters. Alright, so that's going to be about there. So just make a little tiny mark there. Okay, and then I'm going to make another mark up on the forward end. Alright, but here I'm going to use a piece of angle aluminum to help ensure that I have a straight line on this. Alright, so that if it's laying down completely, it should be parallel to the body tube. Alright, and so here I need 10 centimeters roughly. Let's see what I need is another hand here actually. Alright, we can do this. That's going to be right there. Okay, so I just got two tiny little marks there. Now I'm going to attach these in two different ways. So for the aft one, I'm going to use a wood screw and get that into that aft centering ring there. That's actually the trickier one because I'm a bit blind in looking at it. I won't be able to see or feel where I am. The forward one, I will use a T-nut. Okay, now the T-nut does not come with this kit, so what they would have you do is simply attach it with a nut and machine screw like this. But that means you're going to have, at the least, the thickness of the nut projecting into your body tube, and that can end up causing your parachute to get caught. And even then, you want to make sure that you actually cut this back. If you're going to use the nut and bolt here, or nut and screw, you don't want to leave all this excess inside your body tube. That will end up catching something that we don't want caught. Okay. Now for this one, it's less of a deal. All right. Now I don't have an easy way to do all this on camera, so I'm going to take this off camera and drill a couple of holes and then come back. Here I started by drilling a 1/16 inch pilot hole to make sure I'm actually in where I want to be. The centering ring is on this side of the hole, and there's empty space here. So I'm going to try and move that over just a bit. If I can't, this is still fine because I'm going to put epoxy on that screw, and the epoxy will end up getting laid up against that centering ring, and it should be fine. Okay, I'm going to try this again, hopefully it actually hit the center of the ring. Here I have my holes drilled. So I was able to move my pilot hole a little bit here, and then I drilled a 1/8 inch hole through the centering ring. Up front, I used a 5/32 bit, and I might need a little bit bigger one there, but that should be big enough for the T-nut and machine screw. All right, and that's what I've got here. So this is a T-nut. It's also called a weld nut. And then I've got a number 6 by, I think that's a 3/8 inch long screw here. The bronze color doesn't mean anything. It's just what they happen to have in the store. Okay, but the way this works is the T-nut itself will be inside the tube, and then it'll poke up through here with the threaded shank, and our button then goes over the shank, and the screw then screws into that and locks it down. So that inside, it's a relatively flat surface there that's less likely to get anything caught in it. And to make doubly sure, we'll actually spread some epoxy around this once it's been installed. Now, the hard part about this is it takes some long, skinny fingers to get down into the body tube and stick this up through. So we'll see here. Okay, I'm just seeing it there. Okay, looks like I do need to open that up just a little bit. Okay, we'll try a finger extension here. I've got my ruler, and I've put a little piece of masking tape on that with the sticky side up. Alright, this time we're going to leave it on there. Okay, I'm just going to tighten this down with a screwdriver. Now, some people like to leave this a little bit loose to let that rail button kind of rattle around there and slide. You really don't need to. I'd rather have it nicely connected. Now, something you may want to do is, I noticed on these, there's some flash there on the inside of the rail button. It's left over from manufacturing. You want to cut that away, as it will interfere. Okay, so that one's good there. We'll come back to it and add some epoxy in just a moment. All right, coming back to our aft button. All right, this is going to be simply a wood screw. And I'm going to go ahead here and insert that about halfway, so it makes some threads. It still feels like maybe it came out the side a little bit, but as I said, we'll will epoxy this up really well. In the same way, look for flash on this. Yep, there's a piece right there. Cut that away. Preferably without cutting your fingers. Okay, that's good there. Alright, I'm going to make up some 5-minute epoxy and come right back. Here I've made up about 1 gram of epoxy, which should be more than enough for both of those rail buttons. And the first thing I'm going to do is just take a small amount and stick it down the hole. And then I'm going to put the rail button over the screw and then epoxy the threads down here. And again, I'm not going to allow it to rotate anyway, so if you get epoxy on the base, that's fine. Okay, and then we're just going to take a screwdriver here, put that in just until it's against the rocket there. You can see a little epoxy squeezing out. Okay, now up on the forward one, I'm going to change to using a popsicle stick here. Let me see if we can get this to a point where we can see down inside. Well, you're going to have to take my word for it. What I'm going to do now is lay down epoxy on the top of that weld nut and kind of spread it a little bit beyond it. And this is going to give, when it's all hardened, a nice smooth surface that's just going to raise up a little bit, but won't be something that will catch parachutes and shock cords and such. And then I'm going to be sure to allow this to harden in a horizontal position so that that epoxy flows nicely over the T-nut back in there. Okay, we'll come back when this is hardened. The kit comes with a single vinyl decal, and now that the epoxy has hardened, we can go ahead and apply this to the main body part. Okay, so when this is on the pad, either it's going to be on the rail buttons there or on the launch lug. So really the only place we have clear is this side here. Now you can just apply this directly. I'm going to use a little trick that I learned from Apogee, and that is to get some soapy water here. So this is just a little basin of water. It has a single drop of dishwashing liquid in it. Now this has, decal has 2 components. It has a back paper side that we want to remove at this point. And then it's got a clear layer on the front, and we'll remove that after we've applied the decal. Okay, so I'm going to pull off that paper backing. And now I'm just going to run this through the soapy water here. And all this does is temporarily decreases the stickiness of the adhesive there. Okay, and then you want to decide whether you want it to go this way or if you want the rocket turned around to go in the opposite direction. I'm going to go ahead and go with this. And I'm actually going to kind of have mine toward the rear. All right, so here I can just kind of tack it down a little bit and then take a look to see how well I am aligned. Looks like I can actually come down a bit. And this is where that soapy technique comes in handy, is I can easily reposition this. Okay, it looks like it's got a little bit of an angle to it now, but it's more or less the proper position. That looks pretty good. Alright, so once you've got it where you want it, then just take a towel or tissue or whatever you've got handy, alright, and just squeegee that down then. Alright, and then now you can also take off that protective covering layer. And you want to get a little corner up first and then hold it down. Sometimes easier said than done. There we go. You can just pull that back along itself. Okay, and if you need to, you can reposition this again. It's still got the soapy water on there if you haven't squeegeed it out too much. On mine, it kind of made some bubbles as I pulled that covering tape off. All right, so now, once you've got it where you want it, finish squeegeeing out the water. And this will become permanent in about a day or two. Alright, so that's really the only main decal that comes with it. The package illustration has some other graduation themed decals on this. They don't come with it. I actually do have some that I picked up from a hobby store. And so I'm going to go off camera and do the rest of my non-kit included decals, and then we'll come back to put everything all together. Here I've put the whole rocket together and done a little customization with the decal. So I've got mortar boards here on my fins. I've got the name of the college at which I work here, and hopefully lots of people graduate from. Up here on the payload section, the nose is just held in by friction at this point. And so I would recommend putting some masking tape on there to really hold that in. I've had instances of similar rockets where when the payload section reached the end of the reached the end of the shock cord, that shock still popped the nose loose and it came down by itself. And also down here on this coupler, if this is too loose, so if you can shake that loose, you may want to put a little bit of masking tape on that as well. Now, one of the other things you can do up here on the payload section on the nose is use some reusable plastic rivets. Probably just one or two of them on here to help hold that in place. It is also possible to rig this for dual deployment. I have not talked about that at all, and it does require that you get some extra components that are not included in the kit. So with that, I hope you enjoyed building this with me. Have a great launch and a safe recovery, and please stay tuned for more of my videos.